Listen to this. It's an article written by an organ in the first person. I am Jack's medulla oblongata. Without me, Jack cannot regulate his heart rate, blood pressure, or breathing. There's a whole series of these. I am Jill's nipple. I am Jack's colon.
Yeah, I get cancer. I kill Jack.
What I want to move on to now is something that we're really, really fascinated with, and that's going to be stem cell research. Are you real familiar with stem cell research?
Oh, a little bit.
Okay. What I'm curious about is over the recent years, well, stem cell research for me is really fascinating just in general nature, because we're able to repair ourselves essentially with ourselves. Besides all of the controversy and stuff around it. What is your take on the stem cell research with umbilical cord blood, and does it really have the potential that it says it does? What's going on in that field, and where is that field potentially taking us?
There's actually quite a bit going on. In terms of therapies, most of those are more potential than actual. There's a lot of hope here, and people are investigating like mad to find out what can be done. We're looking into the future, though, with this, by and large, except for things like replacing bone marrow, taking it out, and for somebody with leukemia, for example, if you can't eradicate that by standard chemotherapy, you can reconstitute the bone marrow after you just decimate basically everything in the person with the strongest chemotherapy and radiation you can imagine. It's a dangerous therapy, but in fact, it does work. The thing to keep in mind is you hit some interesting things about amniotic cells. I'm not a religious scholar, but I think that those particular sources are more acceptable to, say, the Catholic religion than embryonic stem cells. And what you have to watch out for, what's really interesting, is we talk about cells that are totipotent, that can become anything, and there are others that are just termed pluripotent, which can become a lot of different things, but not everything. And I'm unclear with some of the cord cells and amniotic cells, what kind of potency they have. And they have a lot of potentials. It may be quite interesting to see what we can induce out of them. And there's also the induced stem cells. We can kind of turn these things on. Very, very fertile area of investigation. And as you can imagine, been fraught with difficulty because there's so much religious fervor that gets tied into the origins of these cells and destruction of embryos. And there have been arguments that frozen embryos stored for implantation, for pregnancies that aren't going to be used, that the mom had the baby, whatnot. Yeah. Why can't we use these? And, oh boy, that'll keep theologians and ethicists busy for 1,000 years.
Well, that's when you start talking about ethics and theology, the hot button topics are, again, when does life begin? I am a science-minded individual. If it can further the development of humanity, go for it. I mean, but I have friends that are they're a little leery about it. I mean, some of them see science as complete voodoo, which is laughable in and of itself. But they break it down into, you're playing God. And I think they're throwing that around a little much. Because at some base level, yeah, okay, when do you define life? Great, wonderful. But then, you're starting off with an embryo, and it can be used for so many other things. You have to look at it. It's going to sound terrible. You have the sacrifice of one that may or may not be life for the potential of millions who can be saved.
Yeah, it's quite a battle. When you get into it, it's really hard to parse these arguments.
I mean, I think that the thing that really pushed me in the the right direction, in my opinion, the right direction was reading Dawkins' The Selfish Gene. That pushed me right over the edge. And I was like, all right, this is wonderful. This is what we need to be looking at. This is how we need to be utilizing our information.
Yeah.
Well, do we have the same potential with other stem cells outside of the embryonic ones? Like, say, to get around the whole ethical issue of not using embryos, do you still have the potential with the cord blood, the spinal blood, or the the umbilical blood, or things like that? Do you still have the potential with those stem cells that you would with
do.
But it's harder to pull it out.
They have quite a bit of potential. The real questions are how much, what can you do with them? Because some of them can't quite make every cell that you may need or target. And then how do you control it is quite an interesting problem. There are. It looks like the other sources have great promise, and people are really researching those very extensively now. Because if you can imagine, if we could get a source that wouldn't interfere with anybody's ethics, it would open up NIH funding. And some of the stuff has just been completely cut off because we can't cope with the religious and ethic problems. We can't solve them.
Yeah, because you're damned if you do, you're damned if you don't.
And there's no answer, because no matter what you say, it offends somebody. That has been interesting. It actually has opened up the situation for states like California to say, we'll fund it. And what they're really going for is the payoff in the future, the health benefits, and then the patenting and other things that could come from that. I mean, this will generate an industry of indescribable proportions if it can be solved.
Well, don't you run into, and this might be going out a little bit far-fetched as well, but I know how pharmaceutical companies work with patenting of drugs and such. They're also into the area of patenting genes. Would that potentially cause an issue with the stem cell research as well?
Possibly. We'd have to, this is when you kind of have to get there to see, what are we arguing about? And I'm not clear on the legal status of, can you patent like a wild type gene, but if you start to modify.
Yeah, you can patent modified genes.
Yeah.
Yeah. Now you're off to the races, and we've had a great deal of argument about how the Genome Project would proceed, for example.
Monsanto.
Yeah.
Well, and they certainly have their detractors in terms of their strategies, their corporate strategies have been very interesting. We'll just leave it at very, very interesting strategy that. Remember that corporation exists for the corporation and its shareholders.
Yes.
Not necessarily for the greater public good. It's wonderful when they coincide, but they don't always precisely. And that's where we sometimes get upset or feel cheated or whatever. One of the things that's interesting, though, about the stem cells is they carry an element of danger. And that right now is the thing that I think I'm right on this, that some people who had Parkinson's have had cells implanted to try to basically reconstitute the substantia nigra and get the chemical signal that they need that they don't have. And one of the risks that you have is when you take these stem cells and put them in place, they will grow, but they may come out of control, and that's cancer.
Yeah.
The risk of losing control or being unable to control once implanted with these things is really great, and that will also have to be solved. We'll have to figure out how to shut that off. We may have strategies for it, but it's not easy. We don't have great cures for cancer at the moment, as you can imagine, so it's a long way to go. That said, Parkinson's might be one of the more amenable therapies. I think this came up in the 2000 election or 2004 election. We had huge debates over stem cells.
Yeah.
And it's kind of died down. One of those things that we're not quite ready yet, even for Parkinson's and for Alzheimer's. No way. It's just so far out there. Hopefully we will find ways to regenerate neurons and make them come back or replace themselves as necessary. But thinking that we're going to, in the next 5 years, plug in stem cells and everybody's going to be not demented. No.
Everybody's looking for a magic bullet.
Well, yeah, and that's, we dream of that, but it just isn't going to happen with stem cells. It just is not. We're looking at a long effort here. Lots of time, lots of money.
Okay. Well, that'll bring me to my next topic then. Within the last few months, well, actually way back when me and Lobo first started this podcast, we had ran across an article about a group of people that was actually taking your cells and reproducing them, and they were literally making, I think they still are, printable organs, where they were taking printers, they were taking people's cells, reproducing them, and essentially recreating organs of their own. There was a guy that had a bladder that was printed three-dimensionally. Do you see, where do you know anything about that, and do you see that going anywhere?
No, I haven't heard about that. I'm going to printable organs.
Yeah, you can
really
do a Google
cool.
search on it, actually.
I will.
It's
I
really
will.
cool.
There's a video for it on YouTube as well, where essentially what they're doing is, say you need a liver and your liver is going bad. Well, what they do is they take your liver, they take cells from it, and they cultivate those cells. And what they have found is that human cells are the same size as what inkjet printers, the ratio for inkjet printers to be able to print them out. So essentially what they're doing is they're literally printing organs from your own cells. And it's a process that's been going on for, I guess, roughly 10 years. But they use three-dimensional printers with your cells to print your own organs.
Okay, so they put them on a scaffold of, say, collagen or something along those lines?
Yeah.
I mean, just guessing, this is how I would see it going.
Yeah, it's along the same lines as rapid prototyping.
Oh,
Exactly.
okay. Yeah.
But
That's very interesting, but no, I will have a look at that and
I'll send you the link. Actually, I can send it over to you through Skype in a little bit, because also what they're doing is they're, instead of skin grafting now, they actually take say you burned your hand, you can put your hand into the printer and it literally will print new skin onto your skin.
Oh,
they have a mesh that's a dissolvable mesh that the cells bond to the mesh. The skin cells will bond to the mesh, and then that in turn the mesh will go over top. It's the same way they use the frame to like build you a new kidney. They use this biodegradable mesh, and as your cells coagulate, form, and become solid, the mesh itself dissolves.
Okay.
It's really neat. I'm surprised you don't know about it.
No, I haven't. The closest I've heard is using the mesh and whatnot to restructure injuries, that kind of thing. I didn't realize they were actually spraying cells right into position. That's quite interesting.
Yeah, I'm gonna.
It's actually disturbing to read.
Yeah.
Well,
right now in the Skype window, I've just sent you a link over to one of them, and there is a video on YouTube. For our show notes for the listeners of the show, I'll put the YouTube video up as well into the show notes for the show, and you can actually go and see. They actually have the guy comes out on stage and he talks about it, and he brings the guy out. And they printed him a new bladder, and they say, well, actually, right now as we're talking to you, we have a machine on stage that's literally printing an organ right now, and they show a picture of the machine printing the organ. And then somebody brings him out this container, and it's kind of gross, and he pulls this organ out of this solution, and he says, yeah, here we have an organ right here that was just printed yesterday.
Okay. Well, maybe mean old Dr. Kokjohn can put some comments on their channel. I'll definitely take a look at it and tell you what I think.
Please do.
Yeah,
I haven't heard of that, but there is talk about you bank your own blood for elective surgery. Indeed, we may harvest our own stem cells.
Yeah, I was going to ask you about that too. I know actually of somebody who has done that. They've taken their child's stem cells and stem cell blood and various stem cells from different sources, from the placenta and so forth, and they're banking them so that later on. That's what I was going to go with this. How far off do you see this technology to where it's actually becoming more and more of a benefit? 5 years, 10 years, 15?
Some of that is right now. That
it's being used.
Leukemia, it's now. Yeah. And the banking and all these ideas, I think, are productive for people that have the resources. Yeah, to go ahead and do it and save it, because the technology is coming. And if we can get enough scientists working on basically specific problems, I think within the next 10 years, you'll start to see more and more things where, we can heal this better, we can harvest some of your stem cells, induce them. We're going to get these techniques down, and they will be usable, in my opinion. The induction and whatnot, it looks like, that's something that is in real time. You won't have rejection issues, you won't have contamination issues. I'm very optimistic about this.
Will that be something that the FDA will have to be involved in, or since it's not actually a drug, it's our own stem cells?
Well,
Is that
they'll be
something the FDA will step in? Yeah.
Oh, yeah. It's interesting. Devices are one thing that they do handle, and I don't know where this will fall. This is Full Employment for Lawyers Act, we could call it. we're gonna have to figure out, like, if you print an organ, is that a device? Is it therapy? You see what I mean?
That's a good question. I never even considered that implication.
And I don't know. I honestly don't know. But it will be in fact worked out.
I'm sorry, sir. Your kidney has been patented. You're going to have to pay us a patent fee for your kidney.
Yeah, we'll take it back.
Yeah, right. I got a question for you to kind of go along with this kind of weird, printing of organs and whatnot. Nanotechnology in the bloodstream. Instead of having things repaired from the outside, what's your view on the possibility of it being repaired from the inside through this technology?
It's interesting. One of the things that we study with Alzheimer's disease is actually cardiovascular disease, atherosclerosis, for example, of the vessels that feed the brain, are really a bad harbinger for the future. And it would be very, very interesting if we could have, like, you guys remember this is from a long time ago, the book and movie Fantastic Voyage?
Yep.
Yes.
Yeah, they shrank these guys down and in
the
they
mini
went.
sub.
Exactly. Yeah, and so it would be if we could come up with, let's just say, for example, enzymes tethered to antibodies for something that's eminently doable now, that could maybe attack the cholesterol that's accumulating in the plaque, or tamp down the inflammation, keep the thing from suddenly exploding and sealing off the artery, for example. So if you could come up with other machines or devices, nano devices, that would be an approach that you could use that you just really couldn't get to now, and you wouldn't have to be so invasive. Now we have to track in and kind of put stents in and force this, and the stents don't last. How much better if we could have a little device that could go through and scan and say, oh, here's a problem, and then take care of it. We're a long way from that, in terms of being able to target and make the devices, but indeed we are attacking cancer in a similar model with antibodies that will home right to the place and bring in a toxin, for example. I guess you'd have to call that nanotechnology broadly defined.
Sure.
But we're getting there. It's astonishing. One of the more interesting things that I heard is I'm in Arizona, and there's a company in Scottsdale called Alcor, ALCOR, and they have a website. And
I know about Alcor.
They're cryopreservation.
Yeah.
And one of the things that they're banking on is that nanotechnology and other things will evolve to the point that they will, in fact, be able to repair whatever it was that killed you.
Right.
And bring you back. So that's something that a lot of people have talked about. This is far in the future. They call them cryonauts. You may be in that liquid nitrogen a long time.
Right.
Anybody's able to bring you out. This is really far out. But the theory and the ideas and the technologies, they're beginning to be done now.
I understand the whole. I've read a lot of information on cryogenics, and in case you haven't noticed, I'm a bit of a nerd.
That's why we're so happy to have you on the air with us tonight.
When Rojan told me that you said yes, I about fell over. My jaw dropped.
That's minor.
I was amazed. I'm like, all right, this is going to be, and I was like, what am I going to ask? But I understand the idea behind cryogenics. I understand the foreseeable and the non-foreseeable future, that far ahead of time. But I mean, as far as what liquid nitrogen does to the body and the destruction of the cell structure itself through freezing, there's going to be some intensive amount of work that has to be done on the body inside and out, cell by cell.
Yes.
So I mean, you're talking about. I mean, nanotech. You'd have to put somebody in. That you have to find a way to be able to bring them to a restorative state, and then be able to introduce the nanotechnology or the nanobots or whatever to be able to start working on it, and then for all intents and purposes have this individual in a coma-like state for an extended period of time in order to be able to fix everything.
Yes. I can tell that the Alcor people don't want you around when they're selling their policies.
Right.
At the moment.
Right.
No, those are very good questions that most people don't actually know to ask. Now, it's kind of interesting to think that what they do, if you sign up with them, as I understand it, what they do is when the time comes that they know death is imminent, they have a team ready. And as soon as the physician declares the death, they begin the perfusion process to try to short-circuit some of the damage. I don't know how successful they will be. You know, I mean, I guess probably every case would be individual.
Right.
But, the freezing process is a very tricky one.
It is. I mean, one of the papers that I was reading, they were looking at, I believe it's called a wood frog. It's an amphibian, and it actually has a glucose solution that's found naturally within its cell walls, and it keeps that glucose keeps those particular areas safe from intruding ice crystals.
Yeah.
So that when it does come out of its not cryogenic, but out of its frozen state, there's little or no damage done to this animal.
Yeah.
So that there's garter snakes are able to do this. Certain species of koi, or not species, but subspecies of koi are able to do it, and these particular amphibians are able to do it. So there's a little bit of validity to what can be done, but to be able to introduce that kind of glucose into the system without causing any other detrimental effects seems a bit far-fetched at this point in the game.
Yes.
I have to say that right now I am so tempted to make the Walt Disney's Frozen Head joke that it's darn near killing me, for the record. So, well, now that we've got that out in the open.
There's all these other implications. I actually did something for Paratopia where my question would be if Ted Williams has been frozen, or his head.
Yeah, his head, yeah.
And, if you brought him back, theoretically, and he couldn't hit, could you send him away? See what I mean? The interesting thing is that he's already dead.
Right.
So really, you can't murder him, right?
Right. Yeah. Well. Then again, you're going to run into another question of that would tap the theological mind extremely, because you'd have someone that was brought back. Now that brings into question: was the soul reinstated, or is there no soul to begin with?
Yeah. Was he really dead? Did they know you were going to bring him back? So the soul hang out in some, who knows. Anyway, it's just fun to think about. Yeah,
it is. Absolutely. Yeah. Could you make him go away?
Yeah, really. I'm also envisioning Futurama here with the floating heads in the jars. Sorry. Peanut Gallery, go ahead.
Well, it's as I understand it, that's a less expensive option.
Right.
Rather than the whole body. I think that Walt Disney was never...
No, that was just an urban myth that never actually. Well, supposedly it never actually happened.
Yes.
His whole death was just kept hush hush as much as possible because of shareholders and the people were worried about what would happen with the company and so forth.
Oh yeah.
So I can understand where the legend came from. For a little while, I was doing another piece on another show, and I covered that topic on there. I did a half-hour piece on the legend of Walt Disney's Frozen Head. But it's just one of those neat little topics that gets discussed when you bring up cryogenics and stuff. It always goes back to Walt Disney's Frozen Head. So, Lobo, did you have anything else you wanted to ask him?
Oh, see, again, like I said, when he told me that you said yes, I had like this flood of questions that I wanted to ask, and then I got caught up in the information, and I'm like, oh, I got to do more research, I got to do this, I got to do that.
Yeah, we could very easily have you back on the show many times with the amount of questions that we come across.
I think the one question that I really, I've had friends that have died from dementia and Alzheimer's. I've read a lot of information on the theories of what the onset of Alzheimer's is caused by. And you're a researcher that deals with this. What, to the best of your knowledge, is the primer point that is causing this?
This is the key question that's plaguing us right now. we see the pathology in the classical Alzheimer's pathology. There are these proteins, very sticky proteins that form big globs, call them plaques, in the brain tissue itself and in the blood vessels. And then within the neurons, there are actually conglomerations of a protein we call tau, and they refer to the pathology as tangles. And when we see lots of those, we know those people are probably demented.
Right.
For the longest time, it was thought it's that amyloid plaque. That's the culprit. And I'm not going to kid you guys, 10 years ago, we really thought we had it.
Well, what is that? Explain to people what that plaque is.
It's a small protein, very, very small, just 40 or 42 amino acids long, and it's made in neurotissue. We think possibly in response to injury, possibly in response to poor circulation, for example. But we really don't know what it does. This is one of the problems. We don't exactly know what amyloid naturally does. We just see a lot of it accumulate in people with dementia. And we thought that was the culprit, and we had 10 years ago a vaccination that would get rid of these plaques. And it really worked. And it even worked in the trials, although we had some problems, adverse events, and that trial had to be summarily suspended. The plaques melted away. The dementia stayed.
Huh.
And we haven't quite recovered from this. And, we thought, well, maybe it's a special little part of amyloid that's still soluble. Maybe it's really the tangles now. Maybe it's everything. Our lab heavily favors the idea that the vasculature, or basically the cardiovascular system, begins to fail. Now, this is just an idea. It's not proved. That as you age, heart output goes down, and the brain makes a mistake. It thinks that it's got a leak, that it sees that it's hypoxic, and so it begins to make amyloid to seal blood vessels that would be fine if you were a young person and you had an injury, but in this case it's wrong. And it ends up jamming the works, and it starts this cascade of bad events, and it actually stimulates the brain to make more amyloid because it's getting more hypoxic, and we get this sort of bad situation. That idea is not well accepted by our colleagues, that most people still are focused on the plaque and the tangles, and they think they're going to get rid of those. And, God love them, maybe they will. But we just are in such a pickle now. We've had failure after failure, clinical trials that have attacked amyloid at source. They won't even let the person make the amyloid. And these things, every damn one of them works great in the mice. And you get it in people, and it just doesn't do a thing for us in terms of dementia. It doesn't do a thing. We're stuck. We're in a real rut right now. We're looking at other options. We're trying combination therapies. We're arguing with each other. It's called the amyloid hypothesis. Is that really correct? Do we need to modify it? I mean, it's just really in a state of disarray. And I'm sorry to report that, because we need progress on this disease.
Right.
Bad.
All right. Now, having said that, I know about 10 years ago there was this study that was put out, and in my opinion it was hinky at best, that there was a link between the onset of Alzheimer's and the content of aluminum found in the body.
I was going to ask that myself.
Is there any validity to that?
It doesn't seem so.
Okay.
That the secondary studies and whatnot have not clarified that correlation. There is a person at the Bannerson Health Research Institute who has been able to induce what he feels are amyloid-like plaques in experimental animals with high doses of copper.
Really?
Yes. So some of these ideas kind of come around and go around, and amyloid is a toxic entity, and if you induce its formation by whatever reason, you have some problems that come about with that. Now, I'll just tell you quite bluntly, I look at the plaques that he has in rabbits, and I don't consider them to be morphologically similar to what I see in humans or even transgenic mice. That's my opinion, but it's quite fascinating that he might be able to induce it just by feeding these animals, for example, a high cholesterol diet with a lot of copper. Bad copper. for the
copper's horrible.
Yes.
That stuff will kill you dead.
And unfortunately, the way he found it is feeding the animals our wonderful water.
Really?
I should take that back. I'm not clear on that. I can clarify that. But he noticed that.
Are we talking green blood here, or?
No. I think he had distilled water, and the animals wouldn't respond, and they changed. For some reason, he kind of just backed into this and went, "Oh my God!" And then systematically tried to figure out, what in heck is going on. His name, if you want to search PubMed and look at the papers, I think a lot of them are freely available. As D as in dog, Larry, D.L. Sparks. And he does have quite a number of papers, and he studied the cholesterol connection. Could Lipitor help, for example? That was an accident by just kind of studying people with taking Lipitor. We said, geez, the rate of Alzheimer's appearance is lower here. And those studies have gone back and forth. It's not unexpected because this is complex. As you said before, it really depends on each person's history, their diet, their personal habits, all those things. And so it gets really muddy. And it's not unexpected that the large-scale studies might be very difficult to interpret.
I'm getting a kind of a... This is weird, but I'm getting this kind of connection like you have in the paranormal world where everybody's got their own vision of how something works. And people, A, don't want to share the data, and B, they don't want to relent that maybe their portion of the sandbox isn't the right portion of the sandbox. It sounds like that's kind of what you're dealing with in your world, in your profession, where there's a reluctancy to want to share data there or to agree that, maybe this might work and maybe that doesn't work. You run into that?
Not so much the sharing of data. People are pretty good about that. We do have to wait, for example, with the studies. They have to take them to a certain place. They can't just release data in the middle of them. They have to unblock it. They're done in a blinded fashion. But the sandbox part, you got that right. The only difference is these people all have degrees. And sometimes the egos that go with them is the best way to put it. In terms of you're part of the sandbox, just do the step back and get the perspective on this. You're advising companies to go down this route. Hey guys, it's the amyloid hypothesis. You need to spend millions, and let me tell you, hundreds of millions of dollars have been expended in these studies. They haven't worked. It's very difficult to stand up. In fact, I think it's impossible to stand up at a meeting and go, yeah, okay, it was a great idea, but what the hell?
Yeah.
You see how, status, everything is on the line here. And the thing that you have to keep in mind is that the hypotheses that were looked at and are being investigated now were very reasonable. They're very good interpretations of the data. They haven't gotten us to where we want to be.
But you're all agreeing that the stuff you're coming across does seem to be pointing into some kind of a direction. You're all agreeing on the key points of it, though.
We agree on the overall, this is what we see in Alzheimer's disease. We do not agree on what should be our principal attack focus at the moment. Some people are much more focused on amyloid than others. Our lab, the philosophy is that we think amyloid's in there and important, but it's not necessarily even the thing that starts it. And we're wondering if maybe it's a physiological start, and that is poor circulation, for example, with aging. That's just a hypothesis, but it's quite interesting where this is going. And the turf battles that go on are pretty intense. And, rightfully so. You can't just back up and go, yeah, we're wrong. You need to really figure out why this went foul. For example, what is it that we didn't get from this mouse model, for example, that we really needed to see?
So, to put it in layman's terms, the very basic terms, so you're seeing it more as more of a problem with the plumbing, or would you say it's more of an electrical system issue? Or are you thinking that it might be a cause effect and it might be both?
Well, we think that ultimately it's both. And but it starts out, our model would be, and again, this is just an idea, it's not accepted by everybody, that vascular damage or vascular failure, the brain not feeding itself correctly, for example, starts a series of events that lead to toxic things like amyloid being formed, and somehow that induces the tangles to form. And so we think that, yeah, it starts out maybe as a metabolic imbalance caused by just normal aging. The number one risk factor for Alzheimer's is advanced age. And then from that point on, biochemical responses that maybe in a young person work well to keep the brain functioning when we're injured, but in an old person, just constant chronic sort of activation of these systems ultimately comes back and gets us. If you think about it, for evolution, the amyloid, if it is a sealant, and again, we don't know what amyloid does, which ought to give you the willies about thinking about, well, let's get rid of it. Yeah. But, what does it, and so this is where we are. I mean, this is exactly where we are. And from evolution standpoint, what the evolution needs to do is keep you alive for 40 years. So you can have your kids, raise them, then, drop dead.
You're done. Go get your head frozen.
So these things that happen that might work or you might get away with for a long time, when we have long lifespans, they ultimately catch up with us. And we're starting to see that.
So with the tangles, is that your brain basically? How does your brain go about storing memories, and how is the theory about that worked? Are brains stored? I know your brain fires neurons, which triggers different things in different parts of the brain. So how do these systems how do you think that these systems tie together? That's why I asked about the plumbing and the electrical work, because that's basically how our bodies work. We're plumbing and electrical, and our brains work off of biochemical and things like that. So is it a matter, do they think that, or should I say that you guys think, is it a matter of the tangles stopping electrical neurons from firing and triggering memories properly in certain parts of the brain? Or, how does that believed to be worked?
It absolutely is. The neurons are dying.
Okay.
And the amyloid itself is toxic. We talk about dystrophic neurons, which means that they're oddly shaped and they look really funny, and they're dying. The tangles are killing them from within. The plaques are killing them from the outside. And those neurons are essential. They are the things that connect, that store, that map the memories. With Alzheimer's disease, what we often see first is the hippocampus deep down in the center of the brain. It's kind of like your major mapping center. So let's say today, after the end of the day, when you finally go to sleep, the hippocampus will begin to map memories to permanent locations into basically the brain cortex, the big major part of the brain. Mm-hmm. It's responsible for doing those connections, putting them in the right place, seeing that they get there. The hippocampus is usually one of the first things that's impacted by Alzheimer's. And so those neurons, we see the pathology begin there and radiate outwards. That's where people first lose their new memories. That things that you would remember as a matter of course, they're losing now. Like they repeat things. That the 5-minute memory, I just told you that story.
Yeah.
We talked about Walt Disney. For somebody with Alzheimer's disease, the Walt Disney conversation we had, it's a whole new thing now. In 5 minutes. They can't map any new memories. So when you start to interfere with the ability to connect and to transmit, to go one cell to the other, it's over. It's going to be over in a hurry. Now, the only thing that we can do at this stage is to give people drugs like Aricept, donepezil, and Namenda, and make the neurons that they have left seem to function better, that they signal longer and stronger. But that's it. And ultimately, it's relentless. And every neuron is going to die, and they're going to lose even their oldest memories, the core memories, and they'll become non-functional in the end. So as we lose those, the brain actually even shrinks, and we lose the physical connections that we need. I mean, it's the most devastating picture you can imagine.
Do you foresee a point where possibly you won't be able to stop the virus, to prevent the virus from happening, but ultimately stopping its spread of getting any further to a point where you can kind of put it into a remission or something like that? Is that a possibility?
It is, and that's actually what we had looked for. We looked for with the first clinical trials, is that, you know what? We will be happy if we just arrest it, just hold it in place, because these people are still functional. They have their lives. So far, nothing. it starts, it cannot be stopped. That's literally where we are.
So it almost behaves like a form of cancer then.
It does. And in fact, you guys probably heard about prion diseases.
Yes.
Oh, yeah.
Okay, Stanley Prusner and others feel that Alzheimer's disease shares a number of critical characteristics with these prion diseases like Kuru and new variants, Creutzfeldt-Jakob disease or CJD, mad cow disease of cows, and that it's kind of spreads the same way, and that it starts from a seed, say in the hippocampus, and out it goes. And there's a lot to that, but it's possible. There have been some strategies to stop prions from working. One is actually tetracycline, believe it or not.
Yeah, tetracycline seems to work very well.
And you get in there and you destabilize the kind of formation that these guys make. That hasn't worked for the really vicious prion diseases, but who knows? Maybe in Alzheimer's we'll find that something similar to that might be just the ticket. But we're looking at it along those lines of, we need something now. We really need to examine all the possibilities. So
right, here's a question for you, considering that you stated it. I was going to bring up prions before. Now, we know that they have to be ingested from one form or another in order to be passed on to the next person. What's the possibility that perhaps this is being passed on through something that we're intaking?
There's that possibility. And
I mean, you're not going to get Kuru unless you're eating somebody's brains.
Yeah.
So.
Right. But one of the things that's very disquieting about some of these diseases is, okay, how about this? There are 25 million units of blood transferred each year that we use medically.
Ooh.
If we're moving these things around, it makes you feel real creepy, doesn't it?
Yeah, it does.
Wow.
And by the way, we've done this successfully with hepatitis, hepatitis B, hepatitis C, and HIV. We infected millions of people with medical protocols. With the prion diseases, there is no doubt that the classic prion disease in humans, CJD, has in fact been transmitted by medical procedures, dura mater grafts, basically brain surgery, corneal transplants, etc. That it has in fact been done, and it will spread from the point of inoculation. Alzheimer's disease plaques act in the same way, that we can seed them. And that was a point of contention for a while. Can we get it from our diet? It's probably more like a Kuru thing. Is it catchable? Not really. It's still age-related. Kuru revealed itself by infecting children and women. But it's creepy enough that you do wonder, you do worry.
Yeah, I mean, if that's the case, then we've turned into a superhighway for it.
Well, I joke with the students, but it's not a joke, that HIV, we dodged that bullet. Prion diseases, new variant, basically bovine spongiform encephalopathy, mad cow disease.
Right.
We're lucky, just plain lucky. Maybe the next time. Seriously, HIV was a very slow emerging infection. Millions of people worldwide were infected before we even knew it was there.
Right.
One of these days, and I just tell the students, one of these days, one of you guys is going to do this for real, and we're all going to wink out. And then I just leave.
Wow.
Oh, man. And that's class today.
Dark.
Wow.
Well, Tyler, I guess we're getting to the end of the time here. We've had you on for quite a while, and I think we've discussed every topic under the sun that we could possibly think of off the top of our heads, and then some. Thanks for coming on, man. We really appreciate it. I hope we haven't picked your brain too much and bored you to death.
No. You did forget one question.
Yeah, go ahead.
Whenever you talk to a scientist, you need to ask them, do you have anything to disclose?
Oh.
And by that I mean, for example, if I had stock in the company that produces Pleconero, and I've been talking and complaining or whatever, getting people all upset, write your congressman, don't do that.
Go ahead, we're listening.
But you need to know where people come from. And so it's perfectly legitimate for you to ask people who are talking about Alzheimer's disease, do you receive funding from these companies that are involved? And as it happens, the funding that we get in our lab is from the National Institutes of Health. We have grants. And we don't, both Alex Roher and I decided quite a while ago that we would not take consulting money.
Very good.
Well, Alex made a lot of his income from consulting. It's very lucrative. I had never really had that opportunity, but what happened was Alex got immediately into some situations where he knew that he would not be able to publish the data that we had if he was beholden to these companies, or worse, had signed confidentiality agreements, which they all require. So anyway, what you'll notice is that now when the people do publications, they will have disclosures. So if you read some of these top flight scientists, they'll say, oh yeah, disclosures, and then go to the website and you'll be fascinated to see where they get money. Does it in fact influence their opinions? I don't think so.
Yeah.
I don't. Well, yes and no. I think if they publish something, they're going to be damn careful, because they know that out there in the weeds are guys like Alex and me who would just love to shove it right back down the throat. Okay?
Good man.
And so
Good man.
they have to be careful there. But when you're talking about, in general, we should be doing this and we need more money about that, you need to understand the person's angle.
Right.
And so certainly they might be a lot more enthusiastic than I would be about, say, Alzheimer's immunotherapy if they were involved in the trials. And so that's one of the things I'd say is that always ask people, what's your connection with this before you even start?
That's good to we'll remember that. Thank you.
Yeah, that never even crossed my mind.
Yeah.
I guess it was kind of like when we asked you the questions at the beginning about, big pharma, but I guess that would tie into that.
It would. And indeed, it's not that people necessarily have evil intent, but now at the last Alzheimer's meeting that I went to, everyone is expected at the beginning of the talk to say, I received money from Novartis, Elon, all these people, wherever they get it from, the big companies. So immediately where they stand on some of these issues, and you can act accordingly. Although I don't think it influences their data, there are other things that it might, and so you just need to know that.
Could it influence their sharing of data, though? Because if they're being funded by pharmaceutical company A, obviously they're going to want to get the results themselves to help develop whatever remedy that they're developing for it. And they're, of course, not going to want to have pharmaceutical company B finding out about those results as well.
Absolutely. Absolutely. I can tell you one instance that we had in our lab where we did a study with mice from a company, and they were anxious to have somebody from the outside look at it. We asked them for money, $10,000 or something for comms, which for us is a very small amount of money, believe it or not.
Yeah.
And we go through it like water. And they said, no, we don't give any money out. Okay, but we wanted to do the mice. We got the mice. We did them. The data came out contrary to what they wanted. They couldn't stop us. I mean, they probably sat there and told the lead scientist there, why don't they have confidentiality agreements? They're done. They're cooked. We published it. Of course, we got their input. We came to terms, but there was just no recourse for them. So yes, indeed, if they own the rights to the data, they own the rights to the data. And they can limit what you can publish and how you'll do it. That's what the purpose of the confidentiality agreement is. They've got to protect their corporate assets and shareholders. That's their responsibility.
Right.
And so for us as publicly funded scientists, we don't have those limitations. And it's a different world, totally different world.
Wow. That's scary to think about, though. That's, because again, that's something that's slowing down the flow of progress and has potential to slow it down.
It may. I think there's enough of a rush here that we're in Alzheimer's, we're going pretty well. But yeah, proprietary information is, it's interesting. Just leave it at that.
Well, Tyler, thank you very much for coming on. We'd love to talk to you again in the future. I'm sure within 6 months, we're going to have another notebook full of questions where it's going to be like, hey, can we get a hold of Tyler again?
Okay. Well, you know where I am.
It's been a great pleasure talking to you. Thank you very
Thank you.
much for coming on the show.
Thank you very much.
Thank you.
Take care, man. Bye-bye.
Bye.
Bye.
Are you troubled by irregularity? Then listen to Access Denied, Humans Defective. 9 out of 10 doctors say you'll shit yourself every time. Access Denied, Humans Defective. Download it from iTunes or directly from the show website at accessdeniedradio.com.
Well, that was our interview with Tyler.
Oof.
Yeah, he was really cool. I really enjoyed talking to him. he seems like he had a really good time. I've already been in contact with him. I don't know how many times since the email on Gmail to set up another show in the future about even more topics. Because after we got done recording the show, I think we were on Skype with him for another half hour, 45 minutes at least.
Yeah, easily, yeah. Just
running over other stuff, and we were actually kind of, I think I didn't even realize it, we were putting together the next time he's going to come on the air. And it sounds like he had a really good time. I get the impression that he had a good time here, which I'm really glad about. Now I find stuff all over the internet and I send it to him. He did get back with me, though, on a couple of things. He got back with me about the link that we sent him about the human organs being printed.
Yeah, I read that.
Yeah, he said that, this is for real. That's real science. It actually does do that. And he also sent something back. He said it wasn't a real big deal, but if the fans Google search him, he's involved with a bunch of other projects as like a chairman of the board kind of thing or something like that. But everything that he did was not appointed. He didn't get paid for anything. He does a lot of stuff just for free, advising for companies and advising on projects and things like that. I'm probably saying it wrong, but this, if it was, he said, well, don't worry about it. If your fans search for it, they probably won't. And if they do find something like that, I just wanted to let you know, so I cover his butt. He's real thorough about stuff like that. But, yeah, we covered all kinds of stuff. We covered a lot of topics here. And that's not even including the stuff that we talked about off the air.
Yeah, I know, right?
And it was like 3-something in the morning, and I'm like, no, I got to go. I got to go to bed. If my wife wakes up and sees me still recording, she's going to kill me.
Yeah, no, my middle one had me up within like an hour of getting off the phone.
Oh, man. That show went so long, but it was...
Well worth it. Well worth it.
Yeah, we're going to have him back on sooner than later, I think.
Oh, yeah, absolutely, especially with the interest. Yeah.
Because there was at least probably 3 more topics we could have talked to him about
easily.
and made full shows out of. So.
Easily, yeah.
So if you people enjoyed him, you will be hearing from him again. But I need to do a couple of things here and pay a couple of bills, so to speak. I need to send a big hello to somebody out at where I work. I need to send a hello out to Kat. She's somebody that I work with, and she's one of the few people that I really care about that I work with at my job. And she's a really sweet lady, and she started listening to the show, and I just wanted to say hi to her and let her know, hey, glad you're here. And I also wanted to send a shout out to Transmissions from the Bunker, because some of the things we talked about on this show tonight directly came from their show. The stem cell, some of the stem cell stuff, the capsaicin being used in various drugs to keep people from becoming addicted to them. That stuff we heard a couple of months ago on Transmissions from the Bunker, and I never forgot about it. And I always wanted to address that stuff that they had on that show. So I made it a point to try to bring it up in tonight's show. So if you guys are out there, or Sater, if you're out there and you hear it, hey, you're part of a bigger chain, and what goes around comes around. It's kind of a feedback loop, and you're part of it now. So,
Love you, Sater.
We got an email from Damon, didn't we?
We did.
You want to read it out?
Yeah.
Read it
I'm
out.
going to call him by his pseudonym.
Yeah.
It's, hey, guys, Demon Reaper here, and wanted to say I really liked this episode. The interview was really good in itself. But I enjoyed it even more because in 2007 I went to Ireland for 10 days and had a paranormal experience. I was at Newgrange, which is a huge mound, looking a lot like a small hill with a door that is perfectly aligned with the winter solstice. And as I was on tour with my then fiancée, the rest of the tour group consisted of a bunch of old stodgy English folk. They were extremely rude. The tour group had gone into the passage into the hill, and at the end of the hallway is 3 small alcoves, in which I was standing in by myself. And the tour guide was talking about what it might have been used for when they turned off the lights to show you what it had been like. While the tour guide was talking in the dark, I had that feeling you get when someone was standing really close to you. And I glanced over and saw a man standing next to me, a little taller than me. I stand 5'9", a little stocky, with unkempt hair and a large bush beard. It was dark in the room, but I could get hints that the man's hair was dark brown, and it looked like he was wearing a coarse canvas or burlap shirt. Everyone in the tour besides my fiancée and I had white hair. I instantly knew that the man was not a physical being, but I didn't feel threatened. The man was looking at the tour guide, who was standing in the middle of the room, though I got the impression that he really wasn't looking at her. The tour guide turned the light back on, and the guy was gone. Being analytical, I studied the wall that had been on the other side of the man because it was shale rock stacked to form the walls, and I had thought that maybe the rocks were forming an outline of a person, and my mind was filling it in. There was no apparent recognizable shapes. and a moment later they turned off the lights again. I don't remember why. My mind was on other things than what they were talking about. When the lights went out, I glanced over in the dark as I did the first time, but there was no one there, and I couldn't see any shapes that the wall might be making. Turning my attention back to the tour guide, I got that feeling of someone next to me again, and when I glanced over, I could see this thin, person-like shadow that was the same height of the man who had been there before. The shadow had no definable features, and it looked like as if a person had deflated like a balloon, almost stick-like. After a few moments, the shadow just faded away. Afterwards, I had told my fiancée, and she said that she couldn't see me where I had been standing, and no one else acted like they had seen anything, unfortunately. What a great email.
Yeah, that's probably one of the coolest ones we've gotten so far. And I'm glad he sent it in. And he's writing the email in regards to the interview we did with Mick and Roshan over at the Irish Dublin, Ireland Ghost Hunting Organization. ECPI. And he's that's what he's sending this email in regards to.
Yeah.
And somebody else wrote something too. Mick's been really involved in our Facebook page now, and he's very approachable, and he's has a lot of interaction with people. He's another person that we're most definitely going to have back on because there's been some interest with elementals and things along those lines, and we're definitely going to have Mick back on again, another person that's going to be back on sooner than later. So thanks, Damon. I'm really glad you sent this in. This is really cool. You know,
I've had similar experiences to this too.
Yeah.
I know exactly what he's talking about.
Mm-hmm.
Exactly, because it looks like the person turned sideways and they were like 2D,
mm-hmm.
and then they were gone. It's amazing. I mean, I'm reading this and I'm thinking back to when I saw one, and it was near a mound.
Wow. So yeah, I guess that's everything, isn't it? Did you have anything else you wanted to throw into this one, or are we set for these two?
Shout out to the peeps. Go over to iTunes, leave us a review if you can.
Mm-hmm.
Check us out on Facebook on our fan page, Project Archivist. Go to our website, projectarchivist.com. Give us a phone call or an email at projectarchivist.gmail.com. And what's the phone number again there, Ro?
I don't know where I put it right now. Hold on a minute. I'll just reach over here and drop some stuff and make a bunch of paper noise. Our Google voicemail is 734-681-0459.
Nice.
Please do call and leave us a voicemail if we're able to understand it, and it's cool. We'll throw it on the air.
Mm-hmm.
Well, I think that's it, folks. This is Rojan. Peace out from the D.
This is Lobo from Connecticut.
What?
I got nothing. It's not any better. I'm still here.
Wow. That was like when the trumpet goes wah, wah.
Sad trombone. Sad
trombone. Sad trombone.
Wow.
Peace out, people.
Peace.